Okay, so now we're going to do some multiplication of polynomials. We're going to find some products here. Okay, so polynomial multiplication is basically repeatedly using the distributive property. Okay, it's a repeated application of the distributive property. So for example, this 6x that I'm multiplying times the polynomial 3x squared plus 4x minus 1, I am just going to distribute that 6x through the parentheses. It gets multiplied times everything. So the 3x time, or the 6x times the 3x squared, I'd do that. And I would multiply the 6x times the 4x, and I would multiply the 6x, here we go, 6x times the negative 1. Okay? Now, whenever you are doing multiplication, you multiply the coefficients. Now think about the last lesson. Like bases, what I do with the exponents when I multiply? I add them. Okay? So whenever I do this first multiplication, the 6 times the 3 is 18, but x times x squared is going to be, remember that's the same thing as, if I put it here, 1. 1 plus 2, it's going to be to the third power, so 18 x to the third. Okay, the second one, the 6 times the 4 gives me 24, x times x gives me x squared, and then the last one, 6x times negative 1 gives me a negative 6x. There you are. There you go. So there it is. There's the first example of polynomial multiplication. But that was taking a monomial and multiplying it times something. Okay, so this one is a binomial that we're multiplying times another binomial. Okay, so you may remember this whole thing called foiling. So we're going to see it play out whenever we do the distributive property on this. So I'm going to take the 2x and I have to distribute it to both things inside the 5x minus 1 parentheses. So 2x times the 5x gives me 10x squared. Now I'm going to take that 2x and multiply it times negative 1. I get a negative 2x. Okay? So now I have multiplied, I've distributed the 2x to both things in the second set of parentheses. Now I have to distribute the positive 3 to both things. So positive 3 times the 5x gives me plus 15x. And then the last one, 3 times the negative 1 gives me a negative 3. When I look at these terms here, that 10x squared, that is the product of the first terms. 2x times 5x gives me 10x squared. Okay? And the negative 2x comes from the product of the outside terms, which is the 2x times the negative 1. The 15x comes from the inside terms, the 3 times the 5x. And then finally, that negative 3 is the product of the last terms. First, outside, inside, last. That's usually what we call FOIL. It's an F word. It's a 4-letter F word, FOIL. And we're going to learn another F word here in the next couple of lessons that you will enjoy too. Okay, so the combined and like terms, of course, the two middle ones are going to add up to the 13x. So basically you are distributing everything in the first polynomial to everything in the second polynomial. Okay, I want you to pause here for a second and I want you to multiply this product out. It is a plus b that I'm multiplying times a minus b. Go ahead and take a second, pause it right now, multiply those things out. Okay, so whenever I go to multiply these things out, this is what I should get. The reason why I should get this is because the middle term cancels out. Whenever I go to do foiling on it, the first term, so a times a gives me a squared, as usual. A times negative b is a negative ab. But whenever I go to do the inside terms, I get b times a. I can just switch those around. It's commutative. Those two are going to cancel out. And then finally, the last term's negative b squared. This one has a special name. It is called the difference of two squares. Can you see why? Difference, subtraction, two squares, a squared and b squared. Difference of two squares. I want you to recognize this product. I want you to see it so that you don't have to FOIL it every single time. Look at how this two set of parentheses look. They are exactly the same. They have the same numbers in them. Just the first one has a plus sign in between it. The second one has a minus sign. Whenever I get that, I know it's the difference of two squares. So here's a pro tip on simplifying the difference of two squares. The a squared just comes from the first term squared. The b squared comes from the second term squared. It's the difference of two squares, so you put the minus sign in between it. Okay, so that should be something that you should easily recognize, and you can multiply those things out very, very quickly. Okay, so on this one, I want you to actually pause the video again and multiply these things out. When it says a plus b squared, that means you multiply it times itself. You do not get to use the power property on this. You do not get to go, hey, a plus b squared is equal to a squared plus b squared. Stop doing that. This is not the same thing as the power property because there's the plus sign in between the a and the b. So multiply them times themselves. See if you notice or recognize some sort of pattern here. Okay, so the first one, the 2ab right there in the middle term is the same thing as the product of those two things times 2. The reason why is because it happens twice. You'll have an a times a b and then another a times the b. So you just add them up. It gets doubled. Okay, the only difference between the first one and the second one is that 2ab gets a negative sign. These are also special polynomial products. They are called perfect square trinomials. These are called perfect square trinomials. Trinomials because there are 3 terms in it, perfect squares because, well, like this whole thing, this number a squared is going to be a perfect square. This number b squared is going to be a perfect square as well. Okay, and you may not have a and b inside there. There might not both be variables. You might have something like x plus 3 squared. If you recognize these things as patterns, then it speeds up the process of taking the product. Okay, so when expanding the square of a binomial, here's the pro tip on this one. So the a squared just comes from the first term squared. Okay, the b squared comes from the last term squared. That's just like the difference of 2 squares. However, this one's a little bit different because for the middle term, it doesn't cancel out this time, it adds up. It will be the same thing, so you just double it. It is the product of the 2 terms inside the parentheses and then doubled. A times b and then doubled. This one gets a plus sign in front of that term because I started with a plus sign. So the only difference between this one and the minus is that you're going to get a minus in front of the middle term because we started with a negative sign. Okay? Again, recognizing these patterns are going to help you multiply these things quicker, and it's going to help you whenever we start using that other F word, which is factoring, because you'll be able to work these things backwards much, much quicker. Okay, so again, pause the video, and I want you to multiply out the first ones, and then I'm squaring something on the second one and squaring something on that last one there. So go ahead and pause, give those things a try. All right, so did you recognize those special products? So the first one is the difference of 2 squares, because the things that are inside the parentheses, these binomials, are exactly the same, just one's minus and one's plus. So the shortcut is take the first term, 5y, and square it. When you square it, square both of them, so 25y squared. And minus the last term squared. So the last term is 3, 3 squared is 9, so 25y squared minus 9. The last two are just perfect square trinomials. Now, I wrote out the steps right before I got the answer, but I wouldn't expect you to necessarily do that. Some of that math you could just do in your head and write down what the final answer is. So the pattern is you square, where's my cursor? There it is. You square the first term, so the 4a, that whole thing gets squared. You keep the plus sign for the middle term, and then it's 2 times the product of the first and last term, so 4a times 7. And then the last term gets squared. The last term always has a plus sign on it. Okay, so it simplifies to 16a squared plus 56a plus 49. The same thing happens with the third one here. It is a perfect square trinomial. It's just that I'm going to have a negative middle term. So you square the first term, I get 4x squared minus 2 times the 2x times the 3 gives me a negative 12x, and then finally I get a plus 9 for that last term. Okay, so in the next video we're going to do some more polynomial multiplication because I know you're enjoying it. So why not do more?